Today I would like to talk about another synchronous effect that CADS defines. This one is called defer. Defer allows you to defer the execution of an effectful computation, of a side effect, until a later time. So let's say we are trying to print out the time. We get the time. I'm using time because this way we'll be able to show when we actually took the time sample, or we first referenced the command to take the time sample, and when the actual execution occurs. So we'll be able to show that there's a gap. It's a very simple effect. It's just delaying the execution of an effectful computation. So let's say the original version, the imperative version. So I created a main method which just gets the time, it takes the time, and it prints it out. So that's our base case scenario. This is what it would look like in an imperative style, right? And look in the lower left, it just prints out the time, right? It's 1956:39. Now, the CAT version, which is using the defer effect, what it does is, again, I get the time. I create an IO effect out of it, right? Because in a pure functional program, that's the whole point of all these exercises we're doing here. In a pure functional program, we cannot include a side effect, and getting the time is a side effect because we're accessing the clock, and it's non-deterministic. A pure functional program should only depend on its parameters, its arguments, and it should always produce the same result. This getting the time is the epitome of something that produces a different result every time, and there aren't even any incoming arguments. So it's clearly a side effect. And because it's a side effect, we have to wrap it into an IO effect if you're writing a pure functional program. So that's why this is a good example to use. And it's also a good example to use because we will know when the original construction of the IO effect for time was created, because it's wrapping the time. So what I'm doing here is I'm recording the time. This is just constructing a message, and I ask you guys to please ignore the fact that there's a local datetime now here. That this is only to create a debug message. That's its only purpose in the world. It's not really part of showing how the steps in this demo work. It is just to record a message. Okay, so that we can compare it later. We can look at when we actually issued the defer call, and when the actual execution happened. So that's why I'm creating this message here. So the first real line of the program actually is the second line. So first I create a effect out of the time. And the way I do that is just wrap it in an IO. Now I have an IO effect for the time, right? It's just wrapping the current time. And then I create a deferred version of it by calling the deferred effect. Okay? And what we're trying to show is that when I reference this outer layer, this deferred time IO, that is really when this time statement gets executed. It's not when the time construct, not when this effect first gets created, not when the effect wrapping the time first gets created, but when the deferred version of that gets referenced. That's where this time statement actually gets executed. I ask you guys for a second to consider how defs work and how passing by name works in Scala. This is essentially a very similar concept. because there also you don't actually execute the argument or the passed-in expression until it gets evaluated. So when you pass in by name, the expression you're passing in may never get executed by the method, and a def is evaluated every time you call it. Again, it's a similar thing. Just creating a def will do nothing. When you call it, that's when you get a different result from the evaluation. So I'm just saying these as comparisons to maybe compare, differ to be able to compare, differ to something that you guys are more familiar with. But it's really not a complicated concept, and there are other examples of it just within Scala. Even like I said, passing by name is a little bit similar, and passing and using defs is a little bit similar. So let's look at this for comprehension. So basically, the way these functional programs work in Scala is that everything is just a description. So when you create this sequence of monads, this is just a description of the program, and then the IO runtime of the application runs your program. That's what does the evaluation. Now what you have up here, these are not statements. These are these are just expressions to put together a more complex expression. But these are really the statements of your program that get executed, because it's every line here is a statement that gets executed in this functional program. So then eventually the runtime runs your description of the program. It goes through what's in this for comprehension step by step and executes the steps. Okay. So the first step is just printing out our recorded message, which is up here. This is what I asked you guys to please ignore, because it's not really a part of the sequence of how things get changed in this program. It is only there to show us when we started this experiment. Okay, so we should see a timestamp of the time before, just before we did this time sampling and then deferring, right? And then we wait 5 seconds, and then we do our first evaluation of the outer layer, which is the wrapping effect, right? The defer effect that's wrapping the effect that contains the time, right? The first evaluation, and I print it out, and then I do a second evaluation and I print it out. So the way defer works is that you can create an effect, and you can then you wrap it in a defer, and you can ask for as many times as you want. You can ask for an evaluation. The main point is that the expression inside the effect will not get evaluated until you ask for an evaluation of the outer layer. But you can ask for as many evaluations as you want, and you will get a different result every time. So let's see if we get that. We should have a time recorded. Then we should see the first evaluation being 5 seconds later, and the second evaluation being yet another 2 seconds later. And this is basically, it should demonstrate to us how deferred works. So I'm going to run this now. Okay, so let's look at the lower left corner. It shows that initially we started at 3:25:13, right? No, sorry, it's actually, no, it's 20:03:25, right? So the first execution would be 20:03 it says 31. It's almost 5 seconds. It's more like 6 seconds, but that's still okay, right? We waited 5 seconds, and then there's a second execution 2 seconds later. So again, the key takeaway here is that this now statement that appears to be referenced here at the beginning is not actually executed until the first time IO is executed, which is the outer layer. So there are two wrappings here. First, it's wrapped into an IO effect, and the second time it's wrapped into an IO defer effect. So that's all I wanted to say about defer. That's how it works. If you guys find this content useful, please subscribe and please support me on Patreon so I can continue doing this work and hopefully help a lot of people in the process. Thank you so much for listening.